This is my video for my MEC140 project number 1, the MazeBot. I'm Michael Bachman. Challenge 1 is the timing turns. These first parts here are bloopers, just showing me, my attempts at making the robot go through the maze. And the first 3 I just hit the wall. This time it didn't turn around when I was at the end of the maze. And then that time I'm not sure why it cut off, but my robot went off the ramp on that one. And this is my successful attempt, which is where I have it timed to move forward, turn left, move forward, turn right, go over the ramp, turn right, and then move forward, and then once it gets in that gap, it turns 180 degrees. It says maze complete on the screen as I zoom in and show you. And then challenge 2, here's the bump switch, and my robot's getting stuck on the ramp. This time I made it over the ramp, and then crashed into the walls. Got stuck on the ramp again there. That one almost got stuck, and then crashed into the walls. And this one's another wall crash, unfortunately, and I think this is the successful attempt, where it successfully hits the walls, goes over, almost gets stuck on the ramp, and then finally makes it to the end of the maze, just barely. Luckily, Professor let it count, even though it crashed a little bit. So this part of my video just shows the different phases of the construction of my robot. This image shows the parts I needed for the first photo, which we'll show in a moment here. And that just shows the frame, the wheels, the motors, and the gears for the robot with the shafts. This part shows the motor controllers and the top part of the frame. And then this image just shows the motor controllers installed with the hex standoffs that you can see are used for wire maintenance or wire organization per se. And then the top picture just shows the frame of the robot before the LCD screen, and the Arduino Mega is attached to it, along with the push buttons or the bump switches, and then the battery pack. And then in the final image here, you can see I have 4 hex standoffs standing up the top part of the frame, which the battery pack is resting on top of. And then the final image here shows all of the parts of my robot disassembled, just to show you a full view of all of the components needed, all the screws, nuts, shafts, hex standoff. In regards to troubleshooting, there was a few times where the codes I didn't have it properly coded. I didn't have something in the right place, which meant that it would skip out of the loop or wouldn't enter a loop in the way I had intended it to. And luckily I had Mark to point me in the right direction. He definitely helped me out with giving me clues as to what was causing the issue. As long as he knew what the issue was, which he 90% of the time knew what it was. And then there was one time I had a structural issue where my shaft on one of my wheels was rubbing up on the frame, and I just had to look at it, turn the wheel, kind of tell which one it was, and then just loosen the screws, straighten the frame out, and then make sure all the shafts were turning freely without rubbing up on the frame, and that was able to resolve the issue. And regards to challenge 1, when I kept hitting the walls, all I had to do with that was just trial and error with my timers, and that's how I was able to get that perfect turn at the end there. And that was about all the issues I could think that I had with my design. So I guess that concludes the troubleshooting aspect of my video.